random variable. There's a couple of mistakes I made here. So this is going to be 3-4.2. And I believe sigma x squared is 9. You tell me if I'm wrong. And sigma y squared is 25. Is that right, or 36?
25.
25. All right, and then they say the variables x and y, random variables x and y, are not, or they're not related. They are statistically independent. Everybody with me on this? Just going through, which means whenever you see that, it means rho of x, y is 0, correlation coefficient. If I'm going a little faster on this, realize it's because we've done this already. I'm just trying to get to the point. Everybody with me on this class? So the next thing is, what did they ask me?
Find the variances of u and v.
All right, so u is equal to,
3x plus 4y.
and v is,
5x minus 2y.
all right, now this is the first key thing. When you look at this, we need first to get sigma squared of u and sigma squared of, or this really standard, or the variance of u and v. Everybody with me? Remember, x and y are uncorrelated. So I'll put this formula down here, but this should be something that you commit to memory. Here, if you have something like z is equal to ax plus by as such, then sigma z squared is equal to, and this would be a squared sigma x squared plus b squared sigma y squared plus, and then here it's going to be equal to 2a times b sigma x sigma y times the correlation coefficient. Now, that one you should commit to memory right here. Everybody got me on that? How many know that one? If you've done the problems and been in class, this should be pretty much an automatic, okay? Everybody with me? We can prove it, but we've done that before. So if we have that, the next thing we get is going to be, when we look at this, now we're going to use this, and I'm not going to look there this time. I'm going to look over here. When we get this, sigma u squared, well, I can see for this one, A would be 3, and B would be 4. Now I'm going to put that down, make sure it's clear. Everybody follow me? These are just the coefficients. And remember, those things are dummy variables. It doesn't matter if it's x and y, or it could be anything for that matter, any variables, as long as you know the statistical relationship. And for this one, I'm going to get a squared, or 9 times sigma x squared, plus, and then it's going to be 4 squared, or 16 times sigma y squared. The rest of that is unnecessary to put down because the correlation coefficient between x and y is 0 if they're statistically independent. I'm going to stop for a second. Does everybody follow the reasoning behind this? If you see statistically independent variables, the correlation coefficient of those variables is 0, and that's important. So I have that, and we can write this down, and I want to say that's 481 based on memory from what we did. Then we get sigma v, and that's going to be equal to 5 squared, or 25 times sigma x squared, plus 4, or 2 squared times sigma y squared. And if I don't miss my, if that's not right, let me know, but I think it's 325. We've done this before, I'm just going to punch through this one. Now, after that, we come here. We've got basically the variances of u and v. Now we need the relationship between they're looking for this rho of uv, and this is where I made some mistakes, and I want to make sure I clear it up. Everybody with me on this? So we're going to create that third variable and get rid of one of these two variables. That's the idea. With me, class? So when we do this, I'm going to say, the way he does it, multiply this by 2 and add them. Y'all with me? But another way to do it is we could go ahead and take a look at this one. We could divide by 2 and add. Y'all with me in this class? So you can do it a lot of different ways. You can always get the fact that when you add something where I'm gonna take a coefficient here, and create a third variable, matter of fact, might as well do it. I'm gonna say, u plus 2v is equal to z. This is just a variable with me. Now I go ahead and I say, well, sigma z squared, right here, is equal to, well, this is, well, basically, hold on. Before I do that, I want to do one other thing. I'm going to write down, when I look at this right here, if I do it right, I have 2v, or it's going to be 10x plus 3x would be 13x. And the y's cancel if I do it right. Y'all follow, that's the reasoning. I want to get one variable there in terms of x or y. Okay. And that's just standard. This marker's starting to die too. Okay, I do that, and over here, now I go ahead and I'm going to go ahead and get this. I don't have to put this down this way, but the standard deviation of z, and this is going to be equal to sigma times, or sigma u squared plus 4 times sigma v squared, and then it's going to be plus 2 times 2, and then it's going to be sigma u, sigma v times the correlation coefficient between u and v, and that would be equal to, and here's something I made a mistake on Friday, that should be 13 squared. If you stayed afterwards, you saw that. Who stayed afterwards? Did you see Jay or not? No. You three. Okay, you all remember this class? Okay, so this really should be 13 squared, because when you're taking something and finding a variance, it's always going to be the square of the actual linear terms in this case. So it's going to be quantity, this is a big number, times sigma x squared. And now we can go ahead, since we have sigma u and sigma v, we have those things, we can go ahead and solve for the correlation coefficient. This is where I need your help. So I'm going to go ahead and say that's going to be 13 squared times sigma x squared, which is 9. And then I have to subtract from that sigma u squared, which is 481. I remember doing this stuff. This is ridiculous. Minus 4 times sigma v, 325. And this is going to be all divided by 2. Well, that's actually divided by 4. And then I'm going to just take the square root of 481 and 325 right here. And that should be my row of UV. I don't remember what the answer is. Do you all remember doing this? Remember the form, right, that we're doing over there? Is everybody with me on this one, class? Any questions at all? I know I'm moving a little quick, but I'm just trying to take us to the point on Friday where mistakes were made, and that's one of the things. Y'all with me, class? Now, if you do this, Jagger, I think you did it on your calculator, isn't that right? And input.
Negative 0.1644.
What?
The answer?
Negative or positive?
Negative.
Negative, just check me on this one. I think he's right. Minus, go ahead, 0.1644.
0.1644.
About. I'm sure there's something like that. I think it's 1 over 11, but I don't remember. No, that wouldn't be 1 over 11. Y'all with me on this, class? Did you get that answer? Anybody? By the way, these are painful numbers to just work in your mind. When I was doing this, I hate using calculator if I don't have to. Boy, you need it in this stuff. Did you get that, CJ?
Yeah, that's right.
Okay.
Yeah.
And what's the next part? Isn't it?
That was it.
All right. Now, I want to tell you one other thing, because this is the kind of problems that will drive you a little batty. I'm going to do one in a second. All right, that's the correlation coefficient between u and v. What if we want the correlation coefficient between x and v? Now what do you have to do? Now here's the thing, I want you to think first. You may not know the answer. How many do know the answer? You probably do. There's one key thing. When they ask for a correlation coefficient between anything, think about this. The definition of the correlation coefficient between anything, call it U and V, is going to be the expected value of the product, UV, minus U bar, X bar, or UV bar, pardon me, over, and then it's going to be equal to 2, and here it's going to be equal to sigma U, sigma V. Now, do you remember getting that? This is like the formula that we did 2 lectures or 2 lectures ago, right? It was on Wednesday. All right, that's how you get that. You'll notice it's an expected value that becomes the key. Let's rearrange these things. So the expected value of UV, any two variables, we multiply them together, that expected value will be equal to, and I'll do it this way, 2 times sigma U, sigma V, times the correlation coefficient UV. And then after that, you have to add U bar, V bar to that. Go with me? Now that last part is something you should remember, right? Either one of these two. This is going to be important for a lot of stuff. Everybody okay with that? Now I'm going to keep going. So that's the first part. And the second part on this one, I wanted to make that point on this problem. And if we wanted to do, it's not in there, but if we wanted to find a correlation coefficient between U and X, with me? I want you to make sure you see this. Then we would take the expected value, or if we want that, basically we could create another variable, we can do all sorts of stuff, but if you look at this right here, if we want this correlation coefficient, then we need the expected value of U times, or I should say, U times X, and you would have to expand that. We're going to do this in the next problem. Did you guys look at these problems? Does that make logical sense that this becomes the essential thing? You have to do almost always, if you're going to be with me. Let's see the next problem. And I'll leave that up here. Leave that up here if I can. Let me go ahead. Oh, is there any news on campus today about anything? I heard that, I don't know the results of this, there was some, Eli Manning was here trying to set a world record for throwing toilet paper. What happened?
Not that there was a world record.
It was?
Well, I don't think there was one.
How do you define a world record for toilet paper?
Well, I think he said it was like some couple thousand rolls of toilet paper or something.
How are they gonna figure out what happened during the
They
actual
like
title?
simultaneously broke.
Yeah, something like that. Or they said on 2 oak trees, but it was all the trees. I don't really.
Look, I was here when we won in 2010, 11. Let me tell you something. Everything was white. It was, the whole strip there was white. Matter of fact, a lot of the trees on Sanford's lawn were white. The other side, it was so white, it looked like snow. I've never seen anything like that. That's the only time I've seen that place, literally a different color. The whole place was white, unless there was a snowfall. Did anybody happen to see pictures of that, the national title? The aftermath? It was ridiculous. I think that costed like 2 or 3 times as much as usual to clean it. It was well worth it. Anyway, next problem, 3-4.4. I think that's it, isn't it? Or 3? Is it 3 or 4?
3-4.3.
3, all right. Wait a second, is that the one, read me, because this might be the goofy one.
It says a random variable X has a variance of 9 and a statistically independent random variable Y has a variance of 25.
Go ahead.
Their sum is another random variable Z equals X plus Y. Without assuming that either random variable has 0 mean, find the correlation coefficient for X and Y.
That's not a bad one. But if they, by the way, what is the answer to that? if we have two statistically independent random variables, x and y, and we add x and y together to form a variable z, what is the correlation coefficient between x and y? Anyone?
Zero.
Why is it zero?
Because they're independent.
Statistically independent defines it as zero. Follow me? All right, what's the next part?
Find the correlation coefficient for y and z.
Now that's the one that is important. Everybody follow me? This is the same thing I was talking about a second ago. So first we have sigma x squared is 9 and sigma y squared is 25, right? And there's x and y are statistically independent, correct? Now if we have that, and we're gonna create a value z is equal to x plus y, right? And that means sigma squared of z is going to be sigma x squared plus sigma y squared. The other term we don't need because they're statistically independent. I'm just saying what's obvious, correct, class? Everybody with me on this? I know the note takers, I have to make sure I don't go too fast. If I'm going too fast, just yell. I'll stop. Nope, do you have it? You good? Okay, and that's what, 34? Correct? I didn't do this one on Friday, did I? I didn't have it in my notes this time. Okay, if I've got that, now they want the correlation coefficient between z, right? And they want rho of z and what? X.
Y.
Z and y. So you could get it a few different ways, but how would you get it?
Just rearrange that to be x equals z minus 1.
Here's what I'm gonna do. Yes, you can say that y, since I want that, I can say that y is equal to, this is gonna work, x. And now if I have this, I'm going to have sigma z squared. I'm using the other form, not the form with the mean values, because doesn't it say don't assume a mean is 0 or something like that?
Yeah.
Okay, so this is going to be, this will be by definition sigma z squared plus sigma y squared plus 2. Now for this one, the way I'm doing it, I guess I should call, let's see here. All right, here's what I'm gonna do. I'm using this formula. Well, yeah, this is, got z and y here. Actually, I think I need to let x be equal to,
Z minus 1.
I think this is the better way to do it, like that, z minus y. Now I have an equation, so when I go here, I can get z y, because this is the thing I'm gonna have here. So if I look at this, this is gonna be sigma z squared, sigma y squared. Now a and b, a is 1 and b is minus 1. Can you all follow me on this? And then it's gonna be minus 2 times minus 1, unless I did this wrong. Then it's gonna be sigma of z, and sigma z is 34, or sorry, sigma b square root of 34. And then it's gonna be times the sigma of y, which is gonna be square root of 25 or 5 times rho of zy. Y'all with me on this? Now, I guess the real point I'm gonna make is, to do this equation right here, you really need some function here of zy, and in this case it's a function x, so you can get this correlation coefficient without a mean. I'm not saying it maybe with enough emphasis on this, but If you don't know the means, remember, if we knew the means, we could come over here. And you see that U bar, V bar is equivalent to the mean of the two variables. They said you can't assume 0, or they can't assume any value. Are you with me? So this one, you have to have a formula where you get a coefficient A and B to do this one. Now, if we get this, let's see if it's right. Hold it. Not bad. This is actually going to be sigma of x squared. I'm sorry, I put that down wrong. Are you with me on this class? I'm sorry. It should be that sigma. It should be effectively that z over there, that formula on the far right, should be replaced by x, and then this would follow. Are you with me? Let's see if it works. So that means rho of the cy would be equal to sigma x squared minus sigma z squared minus sigma y squared, and then it's all divided by minus 2 square root of 34, and then times 5. I don't know what that is, but you can tell me.
0.857.
Is that 1 over 11?
Sure.
0.85? No, it isn't. No, wait. 857?
Yes.
Anybody else get that? Class, is that right?
Yes.
Okay, so it's the right answer, which is nice to know. Are you with me? Just trying to get this down. So if that's correct, what's the next thing? Something, I really gotta make this point.
Find the variance of z.
Okay, we're gonna get that, but I wanna make sure you see one really important fact. But to use this formula right here, I really need a form like this. In our case, instead of a sigma z squared, it was sigma x squared, and we had the variable here. So we're basically taking this formula and then just going directly to sigma x squared on this side would be equal to sigma z squared, coefficient here is minus 1, and it's going to be plus sigma y squared minus 2 sigma z, and I think I had sigma x and sigma y on Friday, and I apologize for that. Sigma z times sigma y, and then you're going to have correlation coefficient of zy here. So for this formula, we're going to get A equal 1, B is minus 1, and you can, or plus here. Well, actually it's minus, because that's minus. But that's how you would get the correlation coefficient. I gotta be clear about this, because people will mess this up on quizzes and tests. You all with me? All right, now what's the part again? Next one.
It just says find the variance of z.
Okay, again, the variance of z, right here, is 34. Is that right?
Yes.
Okay, now the only other thing I'm going to caution you about, sometimes the word standard deviation of z would be used, and that's the square root of that. Just be careful that you don't, go so fast you'll make that mistake. And what's the next one?
That's it.
Okay. I think that's, we're going to do 4 too, I think. I had 4 down here. Hold on. I want to make sure I went through. Did anybody here do 4? 4 is the one where you're going to get the weird correlation between, you have a variable w that actually has x plus y plus z, and they want the correlation between w and like x or something. All right, this is an important one, correlation coefficient. Did anybody try this one? Anybody, do you remember I assigned it, didn't I? Okay, nobody tried, good. At least in a sense, I'll have people that are coming at this and they're just gonna have to think through it.
Oh, did you say 344?
Huh?
Did you say 344?
Yeah.
Oh, I looked at it.
Oh, you did look at it? You should, give it a shot. A lot of these problems, I don't wanna look at the solutions manual when I do them, I'm doing them, and I wanna see where the questions would be that you have. And a lot of times, I can see from your perspective how you could get confused about things. And it's very helpful. Yeah, erase all this. I'll leave that there, but, okay. For this problem, we have x bar equal y bar equals z bar equals 0. Is that right, first of all? All the means are 0?
Yes.
And then they say all the standard deviations. These are the kind of problems I love. 1. You can't beat that. I mean, really. All right, after that, they do one other thing. Now they say a variable w is equal to x plus y plus z, and they give you the correlation coefficients, I believe. You tell me if I'm wrong or right about this. Is 0 correct? And then they give you row of, I want to say it's xz, but you tell me if that's what they have here. As 1/2?
That's 1/2.
All right. And then they give you a correlation between y and z as -1/2. This is the kind of problem will throw you if you don't look at it beforehand, or could possibly. With me? So, go ahead. What's the first question?
Says find the variance of W.
Okay. So, what, I guess, I don't mean to say the word so funny. I had a grad student that did that, he got me. If you look at this problem, because it's 0 mean, the variance and the mean squared value are the same. Can everybody see that? Definitely, right? All right, so if I look at this, then I can take a look, and I can say that really, I need w squared, or I need this term to talk about it. We're gonna get the expected value of this in a second, which is gonna be x plus y plus z squared. And now if you look at this, I'm gonna go ahead, we're gonna get the expected value of these terms, but I'm just writing them down without that capital E in front of it. All right, everyone? If I take a look at this, I know I'm gonna have an x squared plus y squared plus z squared. I know that's gonna happen, right? And then I'm gonna have, if you take a look at this, I'm gonna have, if you take the first variable, x, and you multiply it by y and z, I'm gonna have plus, I'm gonna leave room for this, x times y plus x times z, and then plus y times z. Now, I'll tell you what I'm doing here. So I have multiplied all the self terms, the x, y, and z by themselves, that I factored out. Then I have to take x times y, x times z. After that, I take y times x, y times z, and finally z times y, z times x. What happens is all these appear twice if you collect terms. Yup. I should put the 2 here, sorry. Can everybody follow me on that part? In the back. Everybody? Now, if you look at that right there by itself, it's we can go to town on this one. Now, when I get the expected value of w squared, well, that is going to be sigma w squared. That is going to be the variance because the mean value of all those variables is 0. Do you agree, class? So how do you get this part? I think you know. Well, that would be the expected value of x squared plus the expected value of y squared plus, and here it's going to be 2 times the expected value of xy plus 2 times the expected value of xz, and finally plus 2 times the expected value of yz or zy. Doesn't matter. The only thing I'm doing, do you all follow me on this? I want to make sure you do. I'm just trying to take the expected value of every term. Remember, they are not multiplied, they're added, so you can take the expected value of each term that is added. You good with that? All right. Now, if you do that, what are we talking about here? And I know you know this. Well, the expected value of x squared, right, is really sigma x squared plus the mean value, right? Really, that is the standard. It's basically 1. That's what they all are from the definition, right? The variance of x, y, and z are all 1. So this is just 1 plus 1 plus 1. And now how do we get this? Remember, the mean values are 0. I should put this up here. When you look at the expected value of any two variables, minus x bar, y bar here, that's equal to 2, right? Sigma x, sigma 1, or sigma y, rho x, y. I'm just showing you here, right? Remember, for our case, it specified the means are 0, right? And then if we want the expected value of x, y, what did they say? Right off the bat, they're statistically independent, right? It's 0, correct, class? So if I look at this, if these are gone, the expected value of x, y is 0, so that makes life easy, because that means this one can be canceled. All right, now what about this? Remember, that's x times z, right? If you can't read that, I apologize. So it's 2 times the expected value of xz. Let me just put this in. This would be like 2 times, this is xz, sigma x, sigma z, rho of xz equals the expected value of x times z. Y'all follow me on this? Because the means are 0. I don't need to continually show the means here. Okay, everyone? So what's that gonna be? Well, I have 2 times 1 times 1, and what's the correlation coefficient of xz is 1/2, isn't it? So it's going to be this times 1/2, or it's going to be 1. So now I can add another 1. You're going to see what happens. Now, what about this one? The same deal as what I had there, same exact thing, except what happens? Correlation coefficient is negative, -1. Or it's plus minus 1, and that means this whole thing is 3. I think that's right, based on memory. Follow me, class? And then what's the next part?
Found the correlation coefficient for y and z.
All right. You okay with that? You look suspicious.
Oh, no, sorry, wrong part. Found the correlation
What?
coefficient between w and x.
Okay, we'll do that. So which is this?
It was just the correlation
Yeah,
y and z is provided.
Yeah, I was looking at the wrong problem, so. It's,
Wait. Yeah, go ahead.
it's the correlation coefficient between w and x.
Okay, so between W and X, right? How do you want to get that? You know what's nice? The mean values are 0. Okay? The mean values of X, Y, and Z are 0, right? So what I'm gonna, I'll do it over here. I'm gonna get rid of that. And there's several ways to do this, but what they want is a correlation coefficient between W and what?
W and x.
Okay, how are you gonna get that? I'm gonna just say, you can do it 2 ways. So I know if I take a look at the expected value of W times X minus mean of X times the mean value of W, that over 2 sigma W, sigma X, I will get the correlation coefficient between W and X. First, I want to make sure everybody, or W and, yeah, X and W. Agreed, class? Let me stop for a second. Do you all follow the reasoning here? It's critical you do. With me? Okay, now, if you look at that right there, these we know the mean value of x is 0, so regardless of the mean value of w, I can get rid of that. Right? Now, the next thing I take a look at is, that is the expected value of, well, w right there is x plus y plus z, right? Times x, so it's going to be x squared plus xy plus xz. Now just think about this. If w is x plus y plus z and I multiply it by x, I get an x squared plus xy plus xz. Agreed? And then I have to divide that by 2 sigma w sigma x.
Sorry, wait, where's the x squared, xy, xz?
All right, if I have w here as x plus y plus z, and I multiply it by x,
Oh,
so it's going to be x squared plus xy plus xz.
thank you.
Agree with me? I'm not trying to do anything here that's confusing or trying to fly through it. I'm going to keep going on this one. So I'll take these terms, we know what those are. Those are 1 over 2, and sigma w would be square root of 3, isn't it? Yeah. Square root of 3, and sigma x is 1. Then it's times this. Well, the expected value of x squared, if I break it out, is just sigma x squared, isn't it, class? Right? And what is it?
It's 1.
By definition, he gave us that, God, he did. 1 plus, what about xy? Expected value of x times y, what is it and the reason for it? What's the correlation coefficient between x and y? Huh?
0.
The correlation coefficient is 0 by definition, statistically independent, right? That means the expected value of xy is 0. Correct, class? So get rid of that one. What about xz? Let me just get that one. Oh, they give it to you, right? So the expected value of xz is, how would you get it? I need to put that down there, but what would it be? Well, we know what? The mean values of, let me write it down. So we're going to have row of that's of xc. So row of xz is equal to the expected value of x times z, and the mean values are all 0 over 2 sigma x sigma z. Both of those are 1. So the expected value of xz would just be 2 times the correlation coefficient of xz. That's, I guess, kind of a roundabout way of getting to the point. With me, class? So if I put that in there as, well, 2 times 1/2 is just 1. So really, unless I did something terribly wrong, this is 1 over the square root of 3. And is that the right answer?
Is square root 3 over 2.
I think that's wrong in the book. Did I have any notation there?
I think for part C, unless you,
Oh gosh, I hate that. This is the correct way of doing it. You follow me? And if that's the case, the first term has got to be 1. The second term here has got to be 0. The expected value of the third term here, xz, is going to be really 2 times 1/2 or 1. So here, I have 2 and 2. By the way, I'm sorry, this is sigma w down here. Sigma w, if I did that wrong, I apologize. It should be, the 2's cancel. Sigma w should be square root of 3, and sigma x is 1. It should be 1 over square root of 3. And he has square root of 3 over 2.
so
I think that's a mistake. Does he have the same formula as I do? Did you see something?
there's something a little different, so I'm trying to see.
Yeah, somebody with good eyes.
This is something.
think it's wrong in that solution. That's the way to do it. You with me, class? And what's the next part?
Find the correlation coefficient between W and the sum of Y and Z.
All right, you know what we're gonna do, class? They want the correlation coefficient between W and the sum of Y and Z. So, the only thing, and I'll do it over here. So really, what I'm gonna say is, we need the expected value of W, and W is X plus Y plus Z. Do you agree with that, first of all? It's X plus Y, and then Y and Z, right? So now it would be Y plus Z. And I need that. That's what, actually, if you wanna do it this way, just remember this right here. If I take a look at this, the expected value of W times quantity Y plus Z here is the expected value of W times Y plus the expected value of W times Z. I gotta make sure at least you agree with that part before I keep going. Agreed, class? And the reason I'm saying this is, now if we have these two things right here, and this is the expected value of this, I can say, I want to do this correct. If I have the correlation coefficient between W and Y plus Z, it would be the expected value of W times quantity Y plus Z, and then it's going to be minus W bar times Y plus Z bar over, and this is going to be 2 sigma W times sigma of Y plus Z. I'm just writing this down for completeness. Y'all follow me? All right, now I can tell you right off the bat that that expands like those two terms. And I'm not sure how we did it in this book, but I think this will be easier to say. I can't say for sure. So this is going to be 2 times sigma W, sigma of Y plus Z here. And then over here, we're going to have the expected value of W, and that's going to be X plus Y plus Z times Y plus expected value of X plus Y plus Z times Z all over those terms that I have here, and I think I've written everything down right. By the way, in his book, in the solutions, does he break it down X plus Y plus Z as the expected value? He should have something like row of W, comma, Y plus Z. That's what he's asking for, right?
Yes, that he doesn't do that much with the expected values, but I think that answer that he got is wrong. It's written.
Did I read something in it? Yeah, well, it's not uncommon that there can be some problems in it, but basically it's just taking the time to do this part right. Now, I'm gonna just mention this to you, and I want you to follow me to this. If we have a quantity Y plus Z, and, because this is one of the key things. If I just have a quantity, it doesn't matter, call it K, equals Y plus Z, right? There was a correlation coefficient between Y and Z, isn't that right? As 1/2, or minus 1/2? Is that right? Well, let me get to the point. If we have that, and we wanted sigma squared of K, that would be sigma squared, sigma squared of y plus z. Can you follow me on that? Right? Y plus z is, I'm creating a variable so you can see at least that subscript means only that that equation is pertinent to the standard deviation. So that's equal to sigma y squared plus sigma z squared. And that's going to be plus 2a, both a and b are going to be 1 times sigma z and sigma y. Both of those are 1 times rho of yz. Follow me on this, everyone? I don't know if he shows that, but I'm just going through it. With me? Now, what happens here? This sigma squared of y plus z, or what I call k, isn't sigma y 1 and sigma z is 1, right? That's plus 2 times, now isn't rho of yz minus a half? So it's going to be really minus 1, right? Or it's 1. That's my point. Agreed, class? Now, if that's the case over here, I've got, now I can do this. If that's 1, I have sigma of yz right here. Follow me? It's going to be 1. I can erase it right here. I'm just going to follow this one. Sigma of w would be square root of 3, right? Didn't we determine that? I mean, sigma squared of w is 3, isn't it, from prior? So this is square root of 3. Now over here, you got the expected value, and you got of xy, which is 0, plus the expected value of y squared, which is 1, plus the expected value of yz, right, which is minus 1. You all follow me? So that's 0. Can you all follow me on that one? I know I went through it a little fast. I'm trying to get to the point quickly because I know I only got 15 minutes to do something else. What about this one? You can see this is correlated. You're going to have a z squared here, right? Expected value of z squared is 1, right? The expected value of yz is minus 1. The expected value of xz is plus 1, right? So you're going to get 1. Agreed, class? I'm trying to work. I mean, really what I'm doing is if I have z squared at the back, the expected value of z squared is 1. That's the standard deviation, or really the variance of z. zy, the expected value is minus 1 because the correlation coefficient is minus 1/2. The expected value of zx is going to be plus 1 because the correlation coefficient is going to be plus 1/2, right? And then, so really, this whole thing here becomes 1. Now, you tell me if he has this. I think he's got it wrong, but I don't know. Then that means this is going to be 1 over 2 square root of 3. Does he have that? I think he's off.
That's different than both.
I think he's wrong on that one in solutions. And the real way to do it, just do the numbers. And I think he has wrong numbers, if you take a look. It's hard to see, I
This
know.
looks different too, yeah.
I believe he has wrong, but that's how you would do that problem. Do y'all follow me, class? All right, now, the next thing I want to get into, and I didn't leave myself enough time, but it's on me. This is going to be where we have 2 random variables that are either additive or they're subtracted together but uncorrelated, and we're going to get the density function, probability density function of the 3rd random variable z. This is in the next section, section 3-5. It's a very important point. But I'm going to tell you right now, make sure you say or write down something, variables are uncorrelated, and this are statistically independent, either way you want to say it. So here, and this is section 3-5. Here we're going to have something where we say z is equal to x plus y. I'll tell you what the takeaways from this are. And x and y are statistically independent. That becomes critical. Now, it doesn't matter what they are, but they're statistically independent. Then we create a variable z equals this. And what we want to do is find f of z of z. This is the goal. We want to find out how to get that. This is a little bit tricky. Can you all follow me? We got two random variables that are mutually, or that are statistically independent, and we want to find out, if we add those together, what the density, if we knew the density functions of those, and we're assuming, it's not stated explicitly, that we have some f of x, f of y, and that f of x comma y, the joint probability density function, is just f of x times f of y. This is our goal. Here's how we get there. I want you just for a sec. Y'all follow me, class? We want the probability density function of that third variable z, but it's assuming we know the density functions for x and y, and they are statistically independent. Okay. So the way he does it in our Dr. Denny's notes, I don't know if he does it in the book this way, but it's okay. If we have x and y here, and we take a look at the probability, or really we can take a look at f of z, but probability that small, or that capital Z, a random variable, is less than small z, is the same thing as the probability that x, random variable x plus random variable y, is going to be less than z. And by definition, that's the f of z, you might say, of x plus y right here, and that means it's going to be less than z, and of course I can add that. This is something that would be an integration. Can you all follow me on this one, class? I'll put that down what it is, but if you look at this, if we have this equation, z is equal to x plus y, let z be a constant, and we can say y here is going to be equal to z minus x, or we can say x, however you want to do it, is z minus y. Either one is true, but z would be a constant. Y'all with me? Let's take this one. Y is equal to z minus x and just graph it. Well, pick a value for z, and you can see you're going to get a line here, and this would be the region where x plus y is less than z. It would be less than z. Think about this. This is y equals z minus x, right? That's a straight line, right? Minus x, it's going to have a descending slope. And you can think about this, as z gets larger, it's moving this way, this barrier. Now, it's in the notes, but I want to make sure you see this. Everybody see this? Okay. Now, how would you, remember this area is a thing where I have to integrate the probability density function over to get the probability, in fact, that that's true, correct? And you know, if you integrate that f of x comma y, which is f of x times f of y, from minus infinity to infinity, from over x and y, you get 1. You have to know that, right? So what does this boil down to right here? I'll put it over here. That means my capital F right here of z really is going to be an integral. Outside integral is minus infinity to infinity. Inside integral is minus infinity, and this would be 4. I can do dy first through this. I think he has it this way, z minus x, and then I can put fy of y dy and fx of x dx. What I'm only showing you is when you're integrating in the vertical direction, you're going to start at minus infinity, you're going to go up to this point, y, and that point is going to be z minus x. Can you follow me on this, class? So that would be my f of z. Now you'll notice one thing, if the integral's done correctly, this will only be a function of z at the end of the day. Can you see this? You'll integrate out the x and y and you get this. So when you take a look at this, this cumulative distribution function for z, theoretically. But we don't want that, we want the probability density function. This is, it's called Leibowitz's Leibowitz's formula is used for this. If we want small f z of z, we take a derivative of capital F of z with respect to z. And if you look at this, when you actually do this, or you look at that inner integral there, what happens is if you take a derivative of this right here, you're really going to take a look at a function evaluated there times the derivative of this with respect to z, which just happens to be 1. In Dr. Denny's notes, he puts down the actual or the actual formula for this, but it's, you know, when you if you take a derivative, let me ask you this. If you take a derivative with respect to x of an integral from minus infinity to some point f of x here, and you have a dummy integral here, so g of, call it, g of delta d delta here. You know, the only thing you're going to do is evaluate this function at this upper limit, then you have to take the derivative of this with respect to x. Do you remember doing this? Maybe you don't. Without getting into all the details, here's what happens. This becomes the thing that limits it, and you get this. You're going to get, still the first integral is going to be retained because it's going to be multiplying it, minus infinity to infinity. And here, you're going to get f of x times f of y here, and it's going to be z minus x dx. Now you'll notice when you integrate this, x goes away and you have a function just as z. But here's the key. That is the definition of convolution. Can you all sort of see that? Let me define it even further. This can be defined as simply the integral from minus infinity to infinity of f of x of, say, lambda times f of y of z minus lambda d lambda. The lambda integrates out. That is the definition of convolution, if you remember. There's a couple nice things about this, by the way. If I know I have two statistically independent random variables, and I have a third random variable that's just the addition of those two, I can simply take the density function of one and convolve it with the density function of the other and get the final result. Can you all understand that? Now you've had signals, how long ago has it been since you had signals and systems? Well, I'm going to level with you. Of the courses that are really critical is the double E's. Circuits is one of them. I think everybody's had circuits. Signals and systems is another. You're going to use this like all the time in electrical and computer engineering curriculum. And the third would be digital logic and stuff like this. Those are the three things that uniquely identify double E from a physicist or a mechanical engineer or anything like that. So mechanicals, they have signals and systems, and they have, well, they have a reduced complexity type of circuit analysis, but I don't think they get digital. But there's always something very unique about a double E curriculum, and why they want people with electrical and computer engineering degrees for a lot of jobs and not mechanicals or physicists. And the reason is they know all, supposedly at least, they know all three of those. So let me do a problem based on that, because this is the type of stuff, seeing it applied is where it comes into. So if I say I have two statistically independent random variables, x and y, and I have an f of x, I'm going to make this simple, equal to, make it u of x minus u of x minus 1. We're going to make this simple. And I'm going to have, this is f of x, f of y equal to x minus 1, no, u of x plus 1 minus u of x minus 1. I have to multiply that by 1/2 because the area under this has to be 1. Now those are two boxcars they used to call them. If you look at this, and I'm going to show you something that's important. F of x itself of x simply looks like this. This is 0, and this is 1, and this is x. It looks like this. F y of y looks like this. Can you all see this, class? Now, when you do these things, if you remember the definition of convolution, how to do it, I'm going to just try to take you through it real simply. What I always told the class when I taught signals and systems, of the two functions, find the one that's got the most going on, the most variability, the most trouble, you might say. It's this one, because it's not a simple from 0 onward, it's positive, or from 0, less than 0, it's negative. You all with me, or got a value? So I would leave this one alone. And the way you do convolution, the way I always do it is I show it with flip and shift. And you remember, take one of the two, flip it on the axis. That would be basically if it's f of x, it would be f of minus x. And then you move it through the other one and see the overlapping area. And that overlapping area is in fact the multiplied values of the functions will be the convolution. Let me do this for you, and I know I'm running out of time, but I want to make sure I do one of these. So, I'm going to leave this one alone, and let me just write out the definition of convolution without the x and y, because they will not appear there, it'll be only a z. When I have f of z here, of z, technically it's equal to convolution. I can just put down f of x of z convolved with f of y of z, and that is an integral from technically minus infinity to infinity. You can do either one, and I'll take f of x of tau times f of y of z minus tau d tau. Now that's sort of the standard definition. It doesn't matter if you use tau or lambda or any other variable, it's going to integrate out. I'm going to make sure everybody follows me. Now convolution is really important to understand, but I'll show you a trick with a lot of these that I love that gets rid of it. It's using a Laplace transform. And I might add, anytime I don't have to do convolution, it's a good day. Because the Laplace transform is a whole lot easier. So if I take a look at that right there, I can see really what I'm doing is one of these two I'm going to leave alone. It's the one that's most complicated. That's going to be the one down here. So what I'm going to do is rearrange this a little. Let me finish this thought, and I'll be done. So I'll leave up here is my first one, and this is, doesn't matter if it's x or y. This function right here, I'm going to show you. That's from minus 1 to 1 with a value of 1/2 here. Now this is going to be versus tau, and I'll call that f of x right here, tau. Then right below it, from 0 to 1, I have a value of 1, and that's f of y of tau. Okay? Now convolution says, is I have to take one of these and I have to flip it. What I mean is I flip it about the axis, and that's when you just let z go away and you get f of y minus tau. Can you all see this, class? So I'll flip this one on this axis. And if it was right like this, this would be f of minus tau. Everybody follow me on that? Let me just finish this and I'll make it up to you. With me? Now I'm gonna move it a little, I'm gonna add a z there. So if I have this is gonna be my fy of z minus tau. This point is z, and this is gonna be z minus 1. That's the width of this thing. And the height is still 1. Can you all see that? I just flipped it, right? I took that one, I flipped it around the axis, f of minus tau, then I added the z inside the argument. Now it goes like this, and here's the overlapping area. I'm sorry, not there, but here. Can you all see that, class? Now, when we multiply this, 1/2, I made sure it's constant, I don't have a variation there, times this, right? I have 1/2 times 1 is 1, and the width, so 1/2 times 1 is gonna be 1/2. The width is z, that would be the overlapping area, these two multiplied together. How many agree with that? You can see it, can see it. So now I can say that my f of z would be equal to simply 1/2 z, and this would be for z greater than 0, and where would I have to stop? Remember, this goes from 0 to 1, this one's, I'm not moving, but when this window moves all the way to 1, then the whole window is immersed. Can you see that, class? So it'd be from 0 to 1 is z. That's going to be 1/2 z. Now, if you look at this next, there's something I failed to do. What did I fail to do? I didn't account for this part, right? I want you to see this. Remember, when I flip this one here, right, that is between -1 and 0 for z equals 0. But look, that's totally immersed right there. And really what I needed to do, I should have not even done that step, but what I should do is show you that the real way when I flip this to start this thing going is this. I should flip it, but here's -1, and now I should put my thing from z here to z -1, but it should be for z right here between -2 and -1. Can you see that? Because between -2, if z was equal to -1, -1 is -2, 2 minus anything in there, that's where you get overlap in this first part. I'm sorry I didn't do it right off the bat. So if you look at this, here's the overlap area. I'm sorry, I'm taking too much time on this. I'll just finish this up. This one would be fine if it started, the other one started at 0, but for this one, I should say, it would be the integral, and the lower part of that integral starts at -1, and it ends up at z. Can you see this? Ends up at z. And here it's just going to be 1/2 dz, or d tau, and this is going to be equal to 1/2 quantity z minus a -1 or +1, and this would be for z greater than or equal to -2, less than or equal to -1, and that would be the value. Then this is actually moving through here, and when it gets to a value of z equals 0, now it's completely immersed in here, or we get 1/2 times this value of 1. Can you all see that, class? This thing only has a width of 1, so it comes here, it's going to be 1/2 times 1, or it's going to be 1/2 the next part. Just trying to get this out real quick. And this is going to be for z greater than -1, less than 0, but not only there, I mean, it goes here, but it's also going to be true all the way to, what, 1, isn't it, class? Because this has a width of 2. So it's from 0 to 1 here, And then out here, I hope you can bear with me on this one. Now for this thing, when all of a sudden it moves way out here, when I look at this, I'm gonna make this z minus tau. Now when I come here, here's z minus 1. Now that overlapping window is going to be here. This is z minus 1 to 1. Can you all see that as the limits? And if I multiply this, it's just simply 1/2 times 1 times this width, which is 1 minus z minus 1. And that'll be for the next part. So it's going to be 1/2 z minus, I shouldn't say z, I should say 1, my bad. 1 minus z minus 1, and this is going to be for z greater than 1, less than 2, and it's 0 otherwise. Now for this particular one, I'm going to get 1 minus a minus 1, or 2, right? And I'm going to get 1/2 times quantity 2 minus z for this range, and it's 0 else. And that's one of those standard type of functions you'll see, and it looks something like this. If it starts at minus 2, it's going to go all the way to 2. And by the way, I didn't say this, but do you remember how to figure out the total width of a convolve, if you convolve two functions? Say one function has a width of 1, the other has a width of 2. What's the final width of the convolved functions? You add the total widths. So if one is 2 and the other is 1, and width-wise, the total width would be 3. That means, let's see, for mine, this actually should be minus 1. Check on this. I'll give you some homework. I'm going to just stop there because I'm burned. I've really burned a lot of time. We're going to start. I'll make it up to some. Oh, for Friday, the quiz, it'll be related to section 4 and that the stuff 5, but I'm going to focus on section 4, 3 and 4 because those things overlap, okay? The quiz. See you Friday.